Hello, my fellow YouTubers. This is Roy back again. Alrighty, so what are we doing here? We have one complete round of these cores, and I am starting to double up on these guys here. I still have to double up around here. Now, I thought that the wheel with iron in front of every single spoke all the way around would have a bad case of a lens effect. And no, it has more of the Angus effect. And what I mean by that is it seems to want to keep the wheel ticking a little bit further than it would normally without it. Let's go ahead and let's this time turn it clockwise. I just turned it counterclockwise. It's a heavy wheel, so it takes me a little getting used to getting it spinning fast.
Just a shaft by itself.
Nothing hooked up to it, just spinning on its own. And what we have right now is the magnet on the wheel is causing a lens effect, and it's creating a dipole between the iron over here and the magnet itself. So whatever pole is in front of the iron, that iron will turn into the opposite pole, the opposing pole, which therefore will create the same pole that's approaching this will now be out here. So that pole is able to extend itself outward. And if you were to come out here and do something else that's inductively coupled, you would extend that pole all the way out to here, and then all the way out to here. So it can go on forever and ever and ever. It can go out in any direction. And we're going to do some experiments because that's what we do. And the experiment, not today, not now, but later, next video, we're gonna see if we could take the dipole and turn it from being linear and see if we can start tweaking it. So basically, you can see how here we have, let me see, that's a south pole, and that's a north pole, and that's a north pole. So you got two norths, and then you got a south in the middle. And basically the magnetic field here would be that the north is coming out, north is going across and coming out, going around and going back in. And it does come out and turn and go back in. As the field gets weaker, it pulls itself back. So if you were to take that and call it a linear, as well as if you extend it out here, can we extend it 90 degrees? Can we now come off here inductively with another piece of metal and go up 90 degrees? And will that be the continuation of the pole that created the effect in the first place? All right, guys. Gonna leave your comments, all right? Let's go counter. Let's leave your comments. And let me see, there was another experiment I wanted to do, which would be, let me see, take some conductors, aluminum, and now come off the iron, because it's a magnetic field on that iron without the copper. If you put an inductor like this, we'll extend the pole. Also coming up, we'll extend the pole. So we have some good experiments to do because we're going to bring in some aluminum, some copper, some bismuth, and we're going to, for this week, main target on experiments is magnetic field, dipole, which dipole is a magnetic field, and we're going to do a lot of experiments, but we're also going to show how, for instance, if you take a bar magnet and you have a pole on my thumb and a pole over here, you had stretched out and made a wide dipole. But what happens when you get into, say, ring magnets, to where they're only the thickness of the magnet itself? So now the poles on each side of the circle are compressed. And we'll talk about what happens when you compress a magnetic field versus stretching out a magnetic field. And this whole dipole thing, we're going to talk about ether, dipole, and a lot of other good stuff because the dielectric in between the stuff and the ether, we'll call that there's matter and dark matter. So I would say the dark matter would be a dielectric, because dielectrics such as plastics and glass are of materials or are atoms. They're just different types of atoms, so their makeup's different. So basically they're still made of the stuff. So that stuff, it could be two different things, and this is obviously energized stuff that's mixed with the ether. And what we'll do is we'll start getting into a little vacuum as well, because we're going to experiment with different metals under vacuum. And then we're going to bring in crystals, because the crystals is pretty much, I feel, is, if you look at a lot of ore of different elements, crystals is near it. There's always things near it, just like every cow has a bird, every whale has a small little fish, or a shark has a small little fish that eats plankton off the fish, or something like that. But the same thing in nature, you see, is where I'm going with this, because these are the things that will bring out the understanding on levitation. And if Ed did levitate, one of my YouTube followers had asked if Ed used the wheel to change the poles to levitate. And I said, well, if Ed did it or didn't, he talks about it, and he didn't leave anything other than his writings, which show the substance of the base that he calls it, which how it works and what it does. And then you can take it upon yourself to stretch it out and have it do other things. So obviously with my experiments, I'm trying to go through stuff with you guys on, one of my theories would be is that yes, he was capable of doing it, whether he did it or not. You know, I'm on the hunt. You know, why is there a pipe in here? It looks like an antenna. That's his tool. You know, what was he doing with that? Then you got this box, which, you know, if you just take the box off and have the tops tied together, you know, to me it was probably a battery up top. You got cables coming down. Why is there cables, not chains, but cables going to there? So what I think in my theory would be is that yes, it can be done. It's any material, or I would say any element, has a charge. It has a spin, and that charge is reacting to the Earth's magnetic field. The magnetic field is pulling everything to the core. We talk about cores, we talk about magnetic fields, we talk about the center of the core would be the strongest field, which radiates out in a linear, meaning like a pancake coil. So when the field is like this, like a plane, sort of like a solar system where it's flat, or like a CD, and then when you coil out either direction, you're stretching out, so you're creating a wider dipole, and your field, your strongest field is in a straight linear line coming straight down the middle of the core. Very important to know, especially when you get into wrapping your coils and figuring out strengths of coils and what you're looking to create in your creations there. So there you go. So you got your magnetic field, you got your iron, it's being sucked to the middle, and then you got to look at your field and you got to see what direction it's going in and what your stretch is, and then it's conical, meaning that it would be strong strength in the middle, and then it would taper down to the outside. And that's why you'll see some people take coils and make them fat in the front and make a conical cone where it tapers down that way, so the field is stronger because it's going to go like linear. So basically it would be stronger here. And if that's what you're looking to create, or you could have it to where it's a pinpoint, like a focus. So like on the front of these magnets, I would, or the front of these, this is the back, but on the front of these, I would want it more focused at a finger point, because when some of these will be used as a driver and some of these will be used as pickups. So very, very, very interesting stuff, and glad you guys are into it. Peace to Ed Leedskalnin and to all my followers. Leave your comments.